Okay, so today we are going into Module 2, beginning with Module 2.1, and the first thing we'll be looking at is graphing exponential equations. Probably did a little bit of this in algebra, but I need to come back to you. Excuse me, students will learn how to graph exponential equations and solve exponential equations and inequalities. So the standard form for exponential equations is y equals ab to the x power, where y is the answer, or our output, a is the coefficient, the multiplier out in the front, b is the base, and x is the exponent. In an exponential function like y equals 2x, the base is constant, and the exponent is a variable. Okay? To begin graphing, first make a quick table of values. You don't have to have a ton of values in this table, but it is helpful to have probably 3. Then the curve is not going to be a straight line anymore. It's going to be a curve that curves up. Okay? So let's use x and y. And let's just use -1, 0, and 1. Okay? We need to remember with our negative exponents, so this would be y equals 2 to the -1. Anytime we have a negative exponent, it means reciprocal. So we would put that 2 on the bottom and make it to a positive 1, so 1/2. 2 to the 0 power, anything to the 0 power equals 1. And 2 to the first power, of course, is 2. So let's graph that point. So we have -1, 1/2, 0, 1, and 1, 2. So exponential graphs look something like this, curving up. Okay? So in number 2, we have exactly the same graph, except now the multiplier is 2. So our initial output is the same, except we're doubling the y values that we got on our first graph. So we have -1, 0, and 1 again, but I'm taking this first answer of 2 to the x and then multiplying it by 2. So the only thing I need to do is double all of my y values. So double of 1/2 is 1, double of 1 is 2, double of 2 is 4. Let's graph that. You have -1, 1, 0, 2, and 1, 4. So you notice that it's the same type of curve, except that it's much steeper. You probably notice, and you probably might be thinking to yourself, Missy, why are you not going down here, below the x-axis? Well, I want you to think about, see if you can come up with any number we could put in for the exponent that way we would get a number less or equal to 0. So even if we do 2 to the 0 power, well, anything to the 0 power is 1. So that doesn't work. Let's put in a negative number. Well, we already did. 2 to the negative first is actually 1/2. So even if you put 2 to the -5, that's 1 over 32. Still not 0. It's really super tiny, but it's not 0. So it's always approaching the x-axis, but not actually touching the x-axis. So when you get into calculus, you're going to learn that that's called a limit. That x-axis limits us. We're not going to go below that. If I could draw this graph all the way out as far as I wanted and drew this graph really, really large, you would see that our function would actually come really close to the x-axis, but not ever actually touch it. Okay? So now let's do the reverse. Let's do number 3. Let's do y equals 1/2 to the x. So again, do our quick little table of values. You can still use -1, 0, and 1. Let's start the easy way. 1/2 to the first power is 1/2. 1/2 to the 0 power, anything to the 0 power is 1. 1/2 to the negative first means the reciprocal of that raised to the first power. So the reciprocal of that is going to be 2. So your point should be -1, 2, 0, 1, and 1, 1/2. So what do you notice now? Well, it looks a lot like the one we started with, except it's flipped over the other way. Instead of increasing, like y equals 2 to the x, now we're decreasing. See if you can look at those two equations and figure out what the difference might be between y equals 2 to the x and y equals 1/2 to the x. So some of you might be saying, well, I think they're inverse functions. That's partially correct. What's going on is our base is less than 1. So in general, if our base is greater than 1, then we are talking about exponential growth. Okay, it's going to be a growth function. If we are talking about b equals less than 1, our base is less than 1, then we are talking about a decay function. It's getting smaller. Okay? And think about that. If I'm raising a half to a power, any power, let's just write out some powers of 1/2. So 1/2 to the second power will be 1/2 times 1/2, which is 1/4. 1/2 to the third power is 1/8. It's getting smaller and smaller and smaller, but never actually touching 0. Okay? All right, so now we're going to double all of our x values here, at least those first 3, to see what happens to get y equals 2 when our multiplier is 2 times 1/2 to the x power. So let's use our same input. Again, the only thing that's changing is that was our original output. Now we're going to double it. So our original output was 2. We're going to double that to 4. Original output was 1. We're going to double it to 2. Original output was 1/2. We're going to double that to 1. So let's go ahead and graph those. You have negative 1, 4, 0, 2, 1, 1. Okay. Same shape, still a decay function because our base is still less than 1/2, but it's steeper than our original line here. Okay. Okay, so on the next page, it's asking us, compare graph 1 to graph 2. By multiplying by 2 should generate a dilation of the graph, but the graph looks like it has been translated vertically. How do you explain that? So really what it's done, if we look from 1 to 2, it's made it steeper, hasn't it? So it's really stretched upward by a degree of 2, right? It's twice as steep of 2, okay? Graph 3 to 4, what's happening? Not really stretched now. I guess it's stretched, but it's stretched in the opposite direction, right? So for 1 to 2, it's increasing quicker. Okay. In our decay functions, from 3 to 4, it's actually decreasing quicker, right? Getting smaller and smaller and smaller really quickly because it's a decay function. Okay? Yes, still stretched by 2. Okay? But instead, it's not increasing quicker. It is decreasing quicker because it's on a decline. It was this compared to this. This one's much steeper. Okay? Good. Let's go to the next section. Okay, so second thing we need to do is evaluate logarithmic functions. And we've already gone over logs a little bit, but what you really need to be able to do, and I'm going to highlight this a lot, you need to be able to convert from exponential functions to logarithmic functions back and forth with great ease. You need to be able to do that. Okay, that's going to be a really important part of this entire module. If that is challenging for you, I'm going to make it less so on Monday and Tuesday because you're going to get a lot of practice on it. Okay, so let's remember what that is. So when we have an exponent, we have b to the x equals y, right? When we have a logarithmic function, it is the inverse. They are inverse of one another, which means that y equals, so if we take the inverse of that, our log of our base, our answer is y, we're looking for the exponent, okay? Remember that when you are utilizing a logarithmic function, it's kind of a circular motion, and it's b to the x gives us the answer of y, okay? Very important for you to remember how that works. Okay, so all logs have values. There's actually a way when you can't really figure these out in your head, that you have a calculator method to do that. However, you don't really need that method yet. So far, we can use our common sense and we can use estimation to figure out what these values are. So for these first 5 problems, you are going to put them in numerical order from smallest to largest, but you're not going to use a calculator, okay? And be prepared to explain why that is. So remember what this means. This means 2 to some power equals 32, okay? So I know in this case that equals 5. 7 to what power gives us 343? So 7 squared is 49, times another 7 would be 3. So our answer here would be 3. Okay? 35 to some power equals 1. Well, I know that anything to the 0 power equals 1, so my answer here is 0. Let's do it this way. Let's do x equals 5, x equals 3, x equals 0. Okay? 15 to what power gives us 225? That would be x equals 2. 15 squared is 225. And then log 11, 11. 11 to what power gives us 11? That would be x equals 1. Okay? So our order from smallest to largest would be C, E, D, B, A. C, E, D, B, A. Okay? Good. So 3 to what power gives you 81? 3 squared is 9. I have 2 of those. That would give me 4. So x equals 4. 5 to what power gives me 125? That'd be to the 3rd power, so x equals 3. 8 to what power gives me 8? So that would be x equals 1. You hear me saying the same thing over and over again. I want you to get that in your head, because remember, that's what logs help us find. Logs help us find the exponent. 4 to what power gives me 1? That would be to the 0 power. Okay? Now here's something, you're looking at this one going, Miss V, there's no number below there. So when there is no number as the base of the log, we assume that that is 10. Okay? Write this, do a little note down here. So we call those common logs, or base 10 logs. So what that says is it assumes that if there is no log there, log 35, it is assumed that this number down below is a 10. Okay? That's why you don't see it. It's just assumed that that is there. So now if we go back up here, what that's asking us, and you'll see why in a later section, why that base 10 is important. So 10 to what power gives you 100? Well, that would be x equals 2. Nice thing about base 10s, if you have multiples of 10 as your answer, you just count the number of zeros and that's your answer. So if we're ordering again from smallest to largest, you used to get D, C, E, B, A. Okay? Okay, so this row in here, number 9, you're going to see, well, Miss V, I don't know anything that 7 raised to any power gives me 45. So here, these are going to be kind of estimations in this row. So 7 to the 1st power is 7. 7 to the 2nd power is 49. And remember what we're looking for. We're looking for the exponent. Okay? So I know in order to find 45, which is in between my two outputs, it's in between 7 and 49, I know that my exponent needs to be between 1 and 2. Well, let's look at where 45 is closer to. Is 45 closer to 7 or closer to 49? It's much closer to 49. So if I had to estimate, it's pretty close to 49, not quite 49. So I would say that my exponent is about 1.9. Okay, these are estimates. You don't have to be precise. Log 3 to the 12th. Well, 3 squared is 9. 3 cubed is 27. 12 is closer to 9 than 27, so I'm going to guesstimate that it is about 2.1. Okay? 4 squared is 16. 4 cubed is 64. Oh, excuse me. 4 to the 1st is what we need, is 4. Okay? 16 is closer to 2 than 4 is. sorry, excuse me, 12 is closer to 16 than it is to 4. So our exponent is probably closer to 2 than it is to 1. So I'm going to say it's probably, let's see, I don't know, 1.7-ish. If you came up with 1.6, 1.7, you're in that ballpark somewhere. Okay, 3 to what power gives you 30? Well, I know that 3 to the third is 27. 3 to the fourth is 81. So it's much closer to 27 than 81. So it's probably close to 3.1. 3.1, 3.2, somewhere in there. Probably 3.1. Okay. This is asking x to what power gives me x. That would just be, for sure, be 1. X to the first gives you x. We know that for sure. Okay. So if I had to put those in order of smallest to largest, I would have E, let's see, E, C, A, B, D. E, C, A, B, D. Okay? Now we've got fractions going on down here. So now I'm going to ask you, what should all of our exponents be? Are they going to be positive or negative? As soon as I see that I've got 1 over, 1 over, 1 over, I know that all of my exponents are going to be negative, maybe with the exception of this last one. So the easiest way to do that is ignore that fraction for a moment, and then say x to what power gives you x squared. So I know that that would be 2, except I know because of a reciprocal, that must be negative 2, because negative exponents mean reciprocal. 5 to what power gives you 5? That would be x to the first. That I know because it's a 1 over 5, I need to have a negative exponent. So 5 to the first power would give me 5. It's 1 over 5. I know it needs to be, it's the reciprocal of that, which means a negative exponent. 2 to what power gives you 8? 3, so that would be negative 3. Log again, now we have no base this time, so I know it's a 10. 10 to what power gives you 10,000? Nice thing is count up zeros, so 10 to the fourth, except it's going to be negative 4. X to what power gives you 1? Always know that's going to be 0. Now let's list those from smallest to largest, except remember now we're dealing with negative numbers. So it's the farthest negative is going to be our least answer. So we're going to go D, C, A, B, E. D, C, A, B, E. Okay, last one. So these first two are going to be base 10s. Okay, so if we think about it, 10 squared is 100. 10 cubed is 1,000. 200 is much closer to 100 than it is to 1,000. So I'm going to estimate that it's probably about 2.2-ish. It's just an estimate, so you don't have to be exact. Let's see. 10 to what power gives me 2 hundredths? Well, that's 2 hundredths, right? I know that 10 to the negative 2 will give me 1 hundredth. 10 to the negative 3 would give me 1 thousandths. That's kind of taking me in the wrong direction. Ten to the negative 1 would be 1/10, right? So somewhere in between 10 and 20 would be 2 hundredths, because that's between 1 hundredth and 10 hundredths if I change that out. So it's probably between 1 and 2, so I'm going to estimate that it's about, it's going to be negative because I've got 1 over, so negative 2.1, something like that. 2 to the third equals 8. 2 to the fourth, 2 to the fourth equals 16. 10 is closer to 8 than 16, so it's probably going to be 3 point something, so I'll say 3.2. Okay. This is going to be the reverse of that. I can use this same estimate right here for 2 log to 1/10. The only difference is going to be is that it is what? Instead of positive, it's going to be negative. It's the only difference. Log 2 to the 200th, or sorry, log 200 is how you would say that. We're going to come back to that one later. Remind me and we'll come back to that one. Okay? So let's just put in order the ones that we have. We have negative 3.2, 3.2, negative 2.1, and 2.2. So our order would be D, B, A, C. D, B, A, C. Okay, answer the following questions. Is it possible for a logarithm to ever equal a negative number? We talked about this on the last page. Okay, any number that you put in for 2 to the x equals y, even if you put in a negative number, put in negative, we did negative 5. Well, that means 1 over 32. So it's getting, it's really small, but it's not 0. Even if we put in 0, 2 to the 0 power doesn't equal 0, it equals 1. So it is not possible. Okay? There is no number that you can put in as your exponent that you will get 0 as your answer. Is it possible for a logarithm to equal 0? No, we just explained why. Okay? No. Because anything raised to the 0 power always equals 1. Okay? Gets small. Doesn't go past 0 for the first one. Okay? Does log x to the 0 have an answer? Well, that's the same question that we just asked right here, just written in a different way. That's saying x to what power gives me 0? Well, there is no number. No. Okay? No base to anything equals 0. It's not possible. Does log x1 have an answer? That absolutely does. Okay? Because x to the 0 power equals 1. Anything to the 0 power equals 1. Now think about this. Does log x to the 5th have an answer? It definitely does. So if we use our x to some power equals x to the 5th. Well, I have same base. Remember when we did same base before? If I have the same base, then I know my exponents have to be equal. So it does have an answer that's 5. When you see this, when you see a log and your base and the base within the answer are the same, they are canceling operations and your answer ends up being just whatever that number is. Okay? So if you see log 47 to the 5th, those two will cancel out and your answer is 5. Okay? We're going to do some practice ones of those in class, so if it's not quite making sense to you, it will by the end of our class on Monday and Tuesday. Okay, and the last page on your notes is properties of exponents. Definitely review from Algebra 1. Really necessary for you to understand these well so that you can turn around and use them with logarithms. You're going to have a lot of practice on logarithms and exponents in class on Monday and Tuesday. Okay, anything to the 0 power is what? You should know that even through the first 2 pages of these notes, anything to the 0 power is 1. Okay? Using PEMDAS, negative 6 to the 0 power is 1 times 11 would give you 11 as your answer. Okay, this you need to be careful of. Negative 3 to the negative half is not the same as negative 3 in parentheses to the negative half. So this is a really common, this is one thing in algebra that I don't care for. I wish they would do this, because that's really what that means. It's like you're taking your answer and then multiplying it by negative 1. Okay? So 3 to the negative 1/2 is the same thing as 1 over 3 to the half. Excuse me, 3 to the second, not 3 to the half. Okay? So that means we're doing negative 1 times 1 over 9. So your answer would be negative 1/9. Okay? I want you to go ahead and attempt number 20, 21, and 22. Hit pause on your video, try those, and come back and check your work. Okay, so now we're going to check the work on that. So 4 to the negative 3rd, as soon as I see a negative exponent, it means put it down in the bottom and make it positive. You would have a 1 on top. So your answer is 1 over 64. Whenever I see a negative exponent, I want to move it to the other side and make the exponent positive. So what I'm going to do first is move things. I like to move them till they're all positive exponents. They're much easier to deal with. Okay, so now we've just got 9 times 2, which equals 18. 4 to the 3rd, I know is 64. 8 to the 0, remember that's not 0. I hear some of you going, well, that's undefined, Miss V, I can't divide by 0. But 8 to the 0 is not 0, it is 1. So your answer is just 64. Four to the 0 power is just 1, but I'm going to move this up to the top first. So I have 2 to the 5th. So I have 1 times 2 to the 5th is 32. My answer is 32. You're looking at that and going, I have no idea what 29 to the 3rd power is, Miss V. I have to have a calculator for that. I want you to look at that again and think about something. Think about your GEMDOS. What do you do first? Anything that's in the parentheses gets raised to that exponent. So it doesn't matter what's inside that parentheses. If it's raised to the 0 power, your answer is 1. So this whole thing changes out to be 1. Then we're just multiplying by 3. Your answer is 3. Okay, we have 42. Let's put parentheses in like that. Okay, so we have 42 on top. Because that 6 is to the negative 4, I'm going to move it to the bottom and do 6 to the 4th. So to make my life a little bit easier, I'm just going to say 7 times 6, because it's a fraction, I want to leave it as a fraction, do not change it to a decimal. You got 6 times 6 times 6 times 6. Cancel 2 of your 6's out. I get 7 over 6 times 6 is 36, times 6 is 216. 6 to the 3rd power is 216. Okay, try the last 3 on your own. Hit pause on your video and then come back and check your work. And now we're back. Okay, so I have 6 to the negative 1st. I'm going to move that to the top and call that 6 to the 1st because those are interchangeable. Those are equivalent amounts. So I have 3 times 6, should have 18. Right here, I'm going to flip that whole fraction over because I've got negative exponents both places. So 7 to the negative 2 is going to move down to the bottom and become 7 squared. 4 to the negative 1st is going to move up and become 4 to the 1st. So they just swapped places. So then I get 4 over 49. Okay, last one. Or same thing that I did in 27, I'm going to do in 28. I'm going to set up a new fraction line. They're going to swap places because they both have negative exponents. So it's 4 to the 1st over 32 to the 1st, which is the same as 4 over 32. 4 goes into 32 8 times. So we have 1 over 8. Okay, that's it for Module 2.1. We are doing quite a bit of practice in class on Monday and Tuesday. Remember also that you always have suggested problems at the top that you can use for review before a quiz. You can do just to make sure that you're really good at the material. There's not many there. I've given you mostly odd number problems. Any questions that you have on any of those problems you should be bringing to class and be ready to go with so that I can help you with those when I see you. Have a good weekend. See you Monday and Tuesday.